Good morning, class. Today we're going to discuss 9D applications of trigonometry. So here's one application of trigonometry. As you can see, someone is trying to determine the height of this mountain based on the angle they have to make with their heads tilted up to see the top of the mountain. And then they do it twice, measure their angle of elevation of their line of sight so you can measure the height of the mountain, which would be good to know if you're going to hike up it or try and climb up it. So today we're going to do some applications. So we have the angles of elevation to the top of a mountain are measured from two beacons, A and B, at C. These angles are shown on the diagram. If the beacons are 1,473 meters apart, how high is the mountain? So let me first write the given information. The two angles are already given, but we know the beacons, so that's beacon A and beacon B, are 1,473 meters apart. Like that from A to B. So what I'm now going to do is bust this triangle out, this one right here, out of the diagram. I'm going to redraw it so I can do some laws of sines or cosines in order to solve this triangle. What I'm trying to figure out is how high the mountain is. So that would be this height right here. I'm just going to call that X. And I can't find that out now because this right triangle right here does not have any lengths. Like, we don't know any of the lengths, we just know that angle. So it would be good for me to at least know, let's say, the hypotenuse right here. So I can solve for that using my right triangle trig, my SOHCAHTOA. But in order to find that, let me label that as Y. I'm going to have to use some non-right triangle trig on that yellow triangle, that one I've highlighted. So I'm going to redraw that triangle. Here it is. I would like it a little flatter, so I'm going to fix this a little bit. Okay. So let's do some labeling. This angle right here is 29.7 degrees from my diagram. So I redrew the triangle over here. We know we're trying to find Y. The angle that I need that I don't have is this one. Right here inside of the little yellow triangle, but adjacent to that angle. So if I redraw that part, I have my flat part, I have this, and I have inside here is 41.2 degrees. So I know any angle, if it's on a straight line, it has to add up to 180 degrees. So all I have to do is 180 minus 41.2 to find this angle, the angle that's inside of that yellow triangle. So when I do the subtraction, I get 138.8 degrees. 138.8. So I went ahead and took that from here on the diagram and put it into the triangle over there. I need to find Y. I know this is 1,473 meters. So looking at this triangle over here, I can actually find the third angle by subtracting 180 minus the 138.8 minus the 29.7, and I got this tiny one is 11.5. So I wrote inside of there 11.5 degrees right there. And what I want to do is find that y value. So I'm going to set up the law of sines. So I could write then, here are our two opposite. So I have this angle opposite this side right there. That would be my known ratio. So I have the sine of 11.5 degrees over the opposite side equals the sine of 29.7 over y, which will allow me to solve for y. So what I'm going to do here is cross multiply. So 1473 sine of 29.7 degrees equals y sine of 11.5. Now, in order to solve for y, I just have to divide both sides by sine of 11.5. And we can see that those sines of 11.5s will cancel out. So now I'm going to type into my calculator 1473, and I do encourage you to follow along with your calculator, sine of 29.7 and the parentheses, and then divided by sine of 11.5. Woo! And I get that y equals 366. I'm going to round to the nearest whole meter. That is how many meters y is. Okay, so when I look at my diagram here, I have y is 3,661 meters. So I'm going to transpose this information to this diagram. So that is 3,661 meters. Okay, so that's 3,661 meters. And now I'm going to color in this triangle, so we're now focused on that. So with this blue triangle here, because it is a right triangle, I can use SOHCAHTOA on it. So when I look at that 41.2 degree angle, what I want is the x, and x is opposite. So x is the opposite, and what I have is the hypotenuse. I have this 63,661 meters, and we know that's the hypotenuse. And based on our work with right triangle trig, I know that the sine of 41.2 degrees, or the sine of an angle, equals opposite, which in this case is x, over the hypotenuse, which is 3,661 meters. All right, to solve for x, we're going to multiply both sides by that 3661. So when I do that on the left, the 3661 cancels, or on the right it cancels. On the left, I get 3661 sine of 41.2. And I'm just going to check, make sure I'm in degree mode, which I better have been for the previous one, or I would have gotten that one wrong. 3661 sine of 41.2 degrees. It looks like the height of the mountain is then 2,411 meters. So about 2.4 kilometers. So it's over a mile high. That's going to be quite the hike. Or I guess it would be a climb given how steep it is. All right, so we got 2,411 meters. Let's move on to our next example. This one is looking at a box. Find the measure of angle RPV. RPV, so the middle letter gives the location of the angle. So it's going to be located right in here with this little box, and it's not flat on any one of the faces of the box. It actually cuts through the box, that RPV. RPV. Yep, that's it. So what I have to do to find this angle is I'm probably going to be needing some sides that aren't given. I'm going to need PR right here. Let me make that a little thinner. PR. And I'm going to need PV. So RPV, PR, and PV. So those are the two sides I'm likely going to need. And then I'll have to do like law of sines or law of cosines, something like that. So I'm kind of stuck here because I'm like, okay, I don't have either of those sides. I don't have that angle. How do I get started? Well, one thing you look at is you can say, hey, if I know this side, at least I know the side opposite angle P. So that one would be opposite angle P right there. And that would give me one of the sides in this triangle that's drawn cutting through this rectangular solid box. So to find that, because I have a right triangle right here, I can use the Pythagorean theorem. So I can say 5 squared plus 3 squared equals, we can just say c squared. Basically, I'm solving for the hypotenuse there, which is what I've highlighted in yellow. So we know it's 25 plus 9 equals c squared. So c is going to be the square root of 34. And I'm just going to leave that in exact form there, because why make it a decimal if I don't have to? Also, that is not going to be simplifiable. So that gives me one side of that triangle that contains the angle that I'm trying to find, RPV. Now I can consider the fact that this is a box, right? So with a box, this side is going to be the same height as this side, is going to be the same height as this side. Those are all going to be the same. So since those are all the same, this is going to be 3 centimeters. Because all of the box, basically if this is like an Amazon box sitting on the counter, the height of that box, as long as it hasn't been beat up in transition, is all going to be the same. So I can find PV by, again, doing Pythagorean theorem. So I can say that 3 squared plus 6 squared equals, maybe I'll say PV squared, so I can be very specific that it's one of my blue lengths of that triangle in there. So what I get is 9 plus 36, doing my squaring, so I get 45 equals PV squared. Take the square root, that's going to be PV. So I can leave that in radical form, or I can find the decimal. It's also 3 radical 5, but I think I'm just going to leave it non-reduced for this point. So that's a square root of 45. I'll label that. I'm getting so much closer. Oh my goodness. So then the question goes, can I find PR? Can I find PR? Well, again, it's a box. So really it only has 3 dimensions overall. They're just repeated. So if this is 6, this is 6, and then the one behind it is also 6. Those are all 6. So I can say this is 6 centimeters because all those sides will share the same length, it being a rectangular box. And then by that same token, if this is 5, this is 5, and this is 5, those are all 5 because they're all going to be like parallel going around that box. So I'm going to label this as 5. And that's going to help me find PR, which at this point, I think it would be good to know that one, because if I'm using the law of cosines, I will need to know the sides if I don't have any angles. So again, I'll do 5 squared plus 6 squared equals, and then that's PR squared. And so we get 25 plus 36, that's 61 square root equals PR, the length of PR. Because we have 36 plus 25. So now I'm going to redraw this triangle so I can really get a look at what is happening. I'm going to go ahead and erase to give myself a little more room. And so basically, I just have a triangle. PR is 61. PV is going to be 45, square root 45. And then this is QR is square root 34. And the angle I want to find is right here. Okay, so I'm just going to highlight. Those were both green, and this one being yellow in my diagram. So if we want to use the law of cosines, I know you all like A, B, and C better than the rest of the letters in the alphabet because it matches the law of cosines. So I want to find angle A. So the law of cosines equation I will need to use here is A squared equals B squared plus C squared minus 2BC times the cosine of angle A. We want to find A, so that's why we used this one. I know A squared is square root of 34 squared. That's just 34. B squared is the square root of square root 45, or the square root of 45 squared, which is 45. C squared, again, C is across from angle C, is square root of 61 squared. That's 61 minus 2B square root 45, C square root 34 times the cosine of angle A. So this will be a little reminder of how to do this. I'm first going to combine these two, and I get 106 minus, and I think I'm not going to multiply these together. I'm just going to keep them like this. I'll do the actual arithmetic at the end. Then I need to subtract 106 on both sides. Cancel. And I get negative 72 equals negative 2 radical 45 radical 34 cosine of A. Now I have to isolate cosine of A, so I'm going to divide both sides by negative 2 radical 45 radical 34. So then all of this cancels. And I'm actually going to type in my calculator, hopefully you all are following along, negative 72 divided by, and then I need a parentheses, negative 2 times radical 45 times radical 35, or 34. And then I get an answer. I got approximately 0.92, and then it keeps going. I'm going to keep that number in my calculator and then inverse cosine my answer. We know to find angles, we need an inverse trig function. So I do the cosine inverse of both sides, and I get 23 degrees is A, which when I look back at my problem, which you guys will have in front of you, that's actually RPV. So what I'm going to write down here when I write my answer is angle RPV is 23 degrees. And when I look at my diagram, the smallest angle should be across from the smallest side. So here's the smallest side. The smallest angle should be this RPV. It's only 23 degrees. And so it looks like, at least that'll indicate to me that things are going pretty well. Okay. So for this assignment, you can have the power of choice. You can choose any 4 problems that you wish. Feel free to work together as long as it will be productive for you. Thank you and have a great day.